In this video for section 3.3, we're going to talk about something called the factor theorem. And this gives us the purpose for doing synthetic division. So if you were wondering, why are we doing synthetic division? What's the point of dividing a polynomial by something? Here we're going to find out. So dividing a polynomial can help us factor it, and factoring it can help us to find the zeros. So the factor theorem says that if we can divide a polynomial by x minus c and there is no remainder, then x minus c is a factor of the polynomial. And this should make sense because when we think about just dividing numbers, for example, we can divide 24 by 4. 4 is a factor of 24. So it's the same thing here. So if x minus c is a factor of the polynomial, we can set that equal to 0, and we would get c for the value of the 0 or the solution or the x-intercept of the polynomial. And if we know one factor of the polynomial, we can use synthetic division to find the other factors. So synthetic division helps us to factor it if we already know one of the factors. So this is example 6 from the textbook. It says to solve the equation 2x to the third minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0 of the polynomial. So first of all, when you look at this, previously we've done problems with 4 terms using factoring by grouping. However, if I looked at this, I would see that I can't use factoring by grouping on this polynomial because I would factor out a GCF of x squared. That would leave me 2x minus 3, but I can't factor the second pair into 2x minus 3 because I can't divide 11 by 2. So factoring by grouping does not work for this problem. So we need another way to factor it. And that's where this method comes in. So 3 is a 0 of the polynomial. That means that I'm going to do synthetic division and divide by 3. So if 3 is a 0, then that tells me that x minus 3 equals 0, and so x minus 3 is a factor. So I'm going to set up my synthetic division. I'm going to have 3, and then my coefficients of my polynomial are 2, negative 3, negative 11, and 6. So now I'm going to run through my synthetic division, bring down the 2, multiply 3 times 2, that's 6, add negative 3 plus 6 is 3, 3 times 3 is 9, negative 11 plus 9 is negative 2, negative 2 times 3 is negative 6, 6 plus negative 6 is 0. So we ended up with a remainder of 0, which is good. That's what we want to have when we're using the factor theorem. So this tells me that 3 is in fact a 0 or a solution of this polynomial. So now what I have here, this tells me what the other factor is. The other factor is 2x squared plus 3x minus 2. So in other words, I can factor this polynomial into x minus 3 times 2x squared plus 3x minus 2. So now what I need to do to find the other two factors is set this equal to 0 and solve. So this is going to be a problem where I have to find AC because this is a trinomial, 3 terms, and there is a number in front of x squared. So I need to use the AC method here. So 2 times negative 2, this is AC. 2 times negative 2 is negative 4. And then I'm looking for two numbers that multiply to negative 4 and add to positive 3. That would be multiply to negative 4, add to positive 3. That would be positive 4 and negative 1. So I replace the middle term. This should be reviewed from all the way back in section P5. But it might not be too fresh in your mind because we haven't done it for a couple weeks. Replace the middle term of plus 3x with plus 4x and minus 1x. And then factor this using grouping. Split into 2 groups. I can take 2x out of the first pair. That leaves me with x plus 2. And then bring x plus 2 over here. This is going to be minus 1. So my two factors are 2x minus 1 and x plus 2. Now I set each one of these sets of parentheses equal to 0. Draw a line here. 2x minus 1 equals 0 and x plus 2 equals 0. Add 1 to both sides and divide. I get x equals 1/2. And for this one, I just subtract 2 and x equals negative 2. So my solution set for this polynomial is negative 2 and 1/2 and my original solution of 3. So the one that they gave me of 3, I need to include in my solution set. So it's 3, 1/2, and almost out of space there, negative 2. So I need to enter all 3 of those solutions into my lab math. So next you should look at checkpoint problem number 6. Do this in your notes, check your answer, and then move on with the video. I'm going to do one more example here. This is exercise 47 from the textbook, and you're going to see a similar problem in your homework. So they're giving us a graph, and it says to use the graph to determine a solution of the equation. Use synthetic division to verify that this number is a solution of the equation, then solve the polynomial equation. So looking at my graph, I can see that this here is the y-axis, and according to the information along the bottom, my x-axis goes from 0 to 4, and each tick mark represents 1. So if I look at this, it looks like the graph is crossing the x-axis at 2. So I would say 2 is a solution based on the graph. So now I'm going to use synthetic division to verify that this is a solution. So 2 is the number that would go in the box. And then I would put my coefficients of my polynomial, which is this right here. So that would be 1, 2, negative 5, and negative 6. Now I'm going to do synthetic division. Bring down the 1, multiply by 2. 2 goes up here. Add 2 plus 2 is 4. Multiply 4 by 2, that's 8. 8 goes up here. Negative 5 plus 8 is 3. And 3 times 2 is 6. 6 goes up here. Add that. Remainder of 0 means that yes, 2 is a solution. So I've checked that. That worked out as I expected that it should. And now the polynomial that remains here is x squared plus 4x plus 3. So to get the other solutions, I need to solve x squared plus 4x plus 3 equals 0. This one is a little bit easier because there's no number in front of x squared. So we're looking for two numbers that multiply to 3 and add to 4. Got to be 1 and 3, plus 1 plus 3. X plus 1 equals 0. X plus 3 equals 0. And I get my two solutions of negative 1 and negative 3. Now, the way this problem is set up in MyLab Math, they don't want you to put the solution that you got from the graph in. It just tells you to find the other solutions. So I'm going to write here, other solutions are negative 1 and negative 3. So next you should try the homework problems from this section.